Okay, hello everyone, welcome to Code Enzyme. So in this video we will discuss this problem unique median from Codeforces round 997 div 2. And the reason for making this video is simply because I have been struggling with this problem for about 2 days. And finally I solved it. But yeah, I personally feel that this the text that is given in the editorial is not complete. It kind of gives you how to start this, but actually how you can calculate everything after this step. It kind of skips on a lot of things, so I feel that, so I will make this video. Okay, now yeah, so let me open up a board and yeah. Okay, I think this should work. Let me just check. Now if you have not read the problem statement, let me read the problem statement. You are given an array B of m integers. An array B of m integers is called good if when it is sorted the medians are equal. So from this line we can just conclude that if the length is odd, then the medians will be definitely equal, so all the odd length subarrays are good. Okay, now in other words, B is good if both of its medians are equal. In particular, when that is that you are given an array A of n integers, calculate the number of good subarrays in A. Okay, now you can just this is the input format, like you are given an A, and the catch is that it is also given in red that AI is from 1 to 10. Okay, now okay, yeah, that works. Now let's see the sample input for 1111. Okay, let's just discuss this sample input all together. So I think I will just open it like this. Yeah, and maybe we can reduce it to, I think this much works. Yeah. Okay. So let's say, let's go to Zen mode, and this is working now. So first test case is 4 1 1 1 1, and clearly all the subarrays will be good because all the elements are 1. So every time the median will be equal. So simply the number of good subarrays will be n into n plus 1 by 2. So 4 into 5 by 2, which is 20. 10. Okay, which is 10. So that works. Now let's see the second test case, that is 5. Then we have 1, 10, 2, 3 and 3. Okay, now clearly in here what we can do, instead of counting the good subarrays, we can count the bad subarrays and subtract it from the total. So the total, if you see, the total will be equals to 5 into 6 upon 2, which is equals to 15, right? We just need to count the number of bad subarrays. Now for counting the number of bad subarrays, one of the bad subarrays that I can see is 1 and 10, right? All the 2 length subarrays that I can see, like 10 and 2 will be a bad subarray, 2 and 3 will be a bad subarray, like all the 1 length subarray will be good. All the out of the all the 2 length subarray, this is the one that I can see that it is bad. And of the 4 length subarray, I can see like 1, 10, 2 and 3 will be bad. 10, 2, 3, 3 will not be bad because when you sort it, it will become 2, 3, 3, 10. And in here you will have, like, these two will be equal, so it is actually a good subarray, so we can't take this. So the final answer is simply 15 minus 4, which is 11. Okay, yeah, so that is how we are getting 11 here. And similarly you can try counting the bad subarrays for this last test case, and you will reach your answer as 42. Okay, so I will not go into that, but I will just tell you the approach. Now here I will just recommend you that you should first read the editorial, because my solution is basically the solution in the editorial. I read the editorial and tried to understand the solution. So yeah, you can try going over the editorial. Basically what it tries is okay, so basically what they are doing is like, first let's fix an x. Okay, now what is an x? X can be any number between 1 to 10, so you can just loop in this. Okay, so for a subarray to be bad, like for a subarray to be bad, what are the conditions? Like if I say that, okay, I want to count all the bad subarrays such that its median is x. No, not its median is x. X is occurring in it. Okay, x is occurring in it. Okay, so it is like that. We want to count the number of bad subarrays such that x is occurring in it. So let's say I will consider a subarray from A, L to R. Okay, so there will be elements like A, L1, AL, comma AL plus 1, comma AL plus 2 till AR, right? So this will be my subarray. Now in the editorial it says that let us create another array B, and such that bi is equals to, if ai is greater than x, let's assign -1, and if ai is less than equals to x, let's assign +1. Okay, so in the end your a array will become something like 1 1 -1 -1 -1 1 -1 1 -1 and so on. Okay, so we have this a array. Okay, this is the b array. Now I mean it will be a sequence of ones and -1s. Now what does it indicate? Like if let's calculate the sum of b, and if this sum is greater than 0, less than 0 and equals to 0, what you will realize, like if it is greater than 0, that means if the sum is greater than 0, then there are more elements that are less than equals to x and less elements that are greater than x, right? If it is less than 0, then that means that there are less than equals to x, there are less, and the elements that are more than x, there are far more than them, right? And if they are equal to 0, then it means that both are equal. Okay, let's add one more condition, that x is occurring in the subarray. And if x is already occurring in the subarray, that means that these two elements that are there, this element will be x only, right? That will be the smallest xth element, and this element will be some element greater than x, right? So it will definitely be bad. So this array will be definitely bad. Yeah, so that is my conclusion, that what you can do is you need to count all the subarrays in A that are for all x. I mean, this x value is not they are not very much. X can only range from 1 to 10, right? So you can just loop in this range from 1 to 10, or in the arrays of, or you can just loop inside the distinct elements in the array of A. Okay, and then we can set x. Like if my x is fixed, for each x we can calculate the total number of bad subarrays, right? Total number of bad subarrays. So x should be in the subarray, and we just need to calculate the total number of bad subarrays. That is the sum of b l to r is equals to 0. And we also have one more condition, and okay, no, we don't have we already handled it, that x must be in the subarray. Okay, so how do we calculate it? I mean, this much is clear from the editorial, but actually how do we calculate it? You have to actually look at the code and try to understand it, which might be a bit difficult for someone new like me right? So yeah, how do we actually handle it? Now to handle it, what I did was okay, obviously I need a loop from x from 1 to 10, or simply a loop from in the distinct elements. To calculate the sum, to maybe make it like to calculate the sum, I mean I think I will just show you with this example. Let's say 1 10 2 3 and 3. Okay, now clearly for x equals to 2, we have two bad subarrays. One is this one and one is this one, right? Yeah, and also okay, so we have this bad subarray, and for x equals to 3, For x equals to 3, we have this one and this one, right? Yeah. So we need some way to actually first count this 2 and this 2, and we also need to make sure that we don't overcount. We are not overcounting this part, right? We don't need to we need to somehow eliminate this part. Now how do we do that? Okay, so yeah, let's see how we can actually do that. So what I did was, let's say for first of all, let's analyze for x equals to 2. What will we do is let's count, like, okay, first make the B array. So B array will look like, okay, since this is 1, 1 is kind of like, okay, 1 is less than 2, so it will be 1. 10 is greater than 2, so it will be -1. 2 is less than equals to 1, -1, -1. And if you do a prefix sum, so let's start with 1 0 1 0 -1, right? B. And now how do we actually what kind of arrays do we want to count? Okay, so for that, what we will do is we will loop from I equals to 0 to n, right? And let's say I am calculating the sum, so s equals to 0. So at every step I want to do s plus equals to the prefix sum at this step, right? So if I am at this step, I want to get, like, if the prefix sum is 0, I want to count all the prefix sums that are before it and have the sum of 0. Why? Because it will give me the count of the numbers. Like, the sum is equals to, if you know the calculating the sum of L to R in this range using prefix sums, it is equals to P of R minus P of L minus 1. So I mean, it will be constant, so let's just calculate the number of terms that have and if the sum is 0, then we just need to calculate the number of pairs that have P of R equals to P of L minus 1, right? So we just need to maintain this count of P of L minus 1, right? So as I am going, I will also have a map. Let me just write this again. So let's have a map. Okay, so I will have a map of, let's say, intent. I mean, you can make it anything. So let's have a count map, and so for I from 0 to 10, not 0 to 10, it will be 0 to n. And okay, let's also have sum equals to 0. So s plus equals to prefix of I. So whatever the prefix sum, I need to count how many times it occurred before, and that will increase my answer. But there is one problem. How do we ensure that x was in the subarray? That is one thing. How do we actually ensure it, right? So for that, let's say I have some prefix sum. I think this is not a very good example, but yeah. Let's try to think about this. How can we actually ensure it? Let's say x is occurring at some position x, not x, let's take it. Okay, let's say if ai equals x, okay, what happens? So let's say we have some elements al plus 1, then some element a star, then some elements a star plus 1, so on. Then we have some more elements. Wait, let me just draw it again, or let me just say, like, let me just write 10 elements only. A1, A2, not A1, A2, okay, let's say A1, A2, A3, A4, A5, A6, A7, A8, A9, A10. Okay, so let's say if this element and this element were my x, okay, I mean, elements can repeat, right? Because there are only 1 to 10 elements, and there are a lot of numbers, so many of them will be repeating, right? So the proposition is just count the number of subarrays that at least have that number in it. Okay, so for example, in this like, this will be p1, p2, the prefix sum till this point, p3, p4. I will not consider these. I will not push them in the count. till I find this x. Whenever I encounter that okay, a5 was equals to x, I will update my count array, right? Okay, prefix sum I plus plus, like that. I mean, I think I will just show you in the code and then you will better understand. So what we are trying to do is like, okay, whenever ai is equals to x, ignore this for now, but I'm also maintaining a j pointer, like till how much point did I unlock it. Like uh, currently my j is equals to 0 or j equals to 1 because this is 1 based indexing, not 0 based. So let's say j equals to 1. Currently we are here, like we are only considering this part of the subarray, right? Once I reach 5, I will update my count like this, and in here now my map will be updated. Like my map will now consider these elements also. So while j is less than I am incrementing the count of the prefix values. Once this is done, now I can now when I do this, I will have something in my count, right? So that will increase. Like this is counting the number of subarrays. Like when I do it, number of subarrays. So a L2 R such that R equals to I. That means how many subarrays are ending at this point. That is what I am adding here. Okay, and let's say when I reach here, it is not equals to 8, but that is counting the number of pairs that at least have this much. Only this much, not even, I'm not even considering the fifth one. So I'm not, let's see, let me just go back a bit. So when I reach 5, I will in the count hash, I will have the prefix sum of this, like how many times the prefix sum is occurring from I equal to 0 to 5, right? Now when I reach this point, what I'm doing is I'm constantly doing sum plus equals to prefix sum of I. Right, so how many times the prefix sum till this point added. Now this will only looking at this much of this array, right? It is not even looking at this. So I'm not calculating these kinds of subarrays like a to r. So the first element is never that, right? I'm only counting the number of subarrays that are starting from before this and ending at this point, like that. And when I reach this, I will also add these to the count to the hash of the prefix sums. And when I reach here, I will try to find out the number of times like that. So that is the solution. But how do we actually ensure by doing it this way that we are not over counting, right? So let's see if we have 1, 10, 2, 3 and 3. So let's say for x equals to 2, the B array will become, once more let's try it, 1 minus 1 1 minus 1 minus 1, and the prefix sum is simply like, okay, 1 0 1 0 and minus 1. So what will be the count for x equals to 2? Like we traverse from this we can't do anything, the answer is 0. Now I reach here, my map will become like 0. For 0 we have count 1, for 1 we have count 1. Okay, and when I see like, okay, 1 is here, the count of 1 is 1, so my answer will be equals to 1 for this test case. And then I move once more, like how many times do I incur 0. So you will realize like, okay, if I don't take any element also, so I will for 0 I will have one more, so let's make it 2. I mean, okay, let me explain it again. If I take no elements, I still have 0, right? And here is also a 0, so the count of 0 should be 2, not 1. That was my mistake. Okay, so yeah, when I reach here I should count 2. Okay, so answer plus equals to 2. And for minus 1 I can't find a minus 1 till now, so for 2 it will give me 3 bad subarrays, or would it not? I don't think the answer should be 3 for 2. Wait a second, 1 2 and 3. Yeah, actually it should be 3. Sorry about that. Actually it should be 3. Like for 2 we have 3 bad subarrays, right? And let's try for x equals to 3. So my A was 1, 10, 2, 3 and 3. B will be for x greater than 3, so 1, minus 1, 1, 1, 1. So the prefix sum that we have is 1, 0, 1, 2 and 3, right? And now when you do it, you will realize that we are not overcounting. So the answer for 3 should be 0, right? Because let's see. I mean, this first one corresponds to the subarray. This one 10 and 2, right? And these two are and now for 0 we have these two subarrays, that is 2 and 3. And when we one is for this one 0 1 like L minus 1, and one is for 0, like take all the 4 elements, that is 1, 10, 2 and 3. Okay, so these are the 3 bad subarrays that have 2 in them and they are bad. Okay, now for x equals to 3, what we will do is, let's say for x equals to 3 we have this prefix sum, and yeah, let's try for going from left to right. So my count is actually like a hash map, and this is my answer, which is currently 0. So for I equals to 0 we still haven't encountered 3, so for all these the answer will be 0. When I reach here, I will update my prefix sum for these 3 values. So it will be like 1 is occurring 2 times, 0 is occurring 1 times, but I will write 2 because if I consider no elements it will still be more, right? So let's say 2. So, and now when I reach 3, I am looking at prefix sum of 2, and this is prefix sum of 2. So I see that 2 has not occurred, so answer will still be 0. When I reach here, I will also append for these 4 elements, so 2 is occurring once, right? But I am asking for prefix sum of how many times 3 is occurring, so answer will still be 0. So the number of bad subarrays for x equals to 3 is still 0. Okay, that is because we are continuously incrementing the prefix sum. That is how we are avoiding the test case, that the case where we have this kind of problem, that overlapping problem, because we don't really want to count these two subarrays for x equals to 3 also, right? So yeah, that was the solution. Let's quickly finally look at the code once more. So we have so I'm actually traversing from x equals to, first of all I'm just calculating the number of unique x's, because I don't know why I didn't want to go from 1 to 10. So yeah, you can also do this, and then you create the prefix sum. Here I am using prefix sum 1 based indexing, but you can also go for 0 based, totally your choice. And then I am creating the B array, and also in the same loop I am also calculating the prefix sum. Then okay, so underscore sum is the number of bad subarrays for each x, and this is my count. You can also use an order map with some reserve capacity, that will also work. And let's start with j equals to 0, and whenever I equals to x, I am also maintaining a check, because count of 0 is 1, but that is only what I have to consider for one time only. I don't really need to put the count of 0 many times equals to 1, otherwise it will give me a wrong answer. Rest is I think pretty much obvious if you followed the video. So bad total plus equals to sum, and in the end you can just subtract it from the total like that. So I will give this code in the description, and if you learned something and if you are able to solve this, kindly like this video, subscribe to the channel, and I will see you guys next time. Thank you.